Let's get started. So we have just added several physical properties to our list. And the reason that we've done this, we started out talking about physical properties. You may remember way back when we started this lesson, this unit, and I gave you an object and I said describe the object. And we talked about the way scientists describe matter. And one of the things we talked about was we call these things that the matter has physical properties. However, I have not really talked to you much about why we're doing this because of what's going to be on TCAP. Here's what's supposed to be on TCAP about this. You're supposed to be able to tell the difference between a physical property and a chemical property. Now, have we talked about chemical properties? No, we haven't. That's on purpose. And we have a pretty long list of physical properties right now. And there are many more that aren't on there. For me to try and I could spend all school year just doing different physical properties. There are that many. What I wanted to do was get you familiar with the most common ones. So when you see these that we have on our list, you should be able to recognize, oh yeah, that's a physical property. But chemical properties, we've not talked about at all. But there is a trick that you can use that works every time. And it will help you know if a property is a chemical property or a physical property. Now, here's what I want to do. I want to get your brain back into that way of thinking about describing matter according to its physical properties. Now, oh my, hold on. Let me unfreeze right here. You should recognize one of these bad boys, right? No. Yes. What is that thing? Gosh, it really dominates our every week. So here's what I need you to do. You've got a list of physical properties in front of you. I hear someone talking while I'm talking. You have a list of physical properties in front of you, and you have a list of physical properties in your head. Tell me one physical property about this scientist notebook, this hypothetical scientist notebook. What's one physical property of it? Gabe?
It's composition.
Yeah, well tell me its composition.
It's made out of like paper and kind of like a harder material.
Yeah, so paper, pulp, cardboard, probably some fibers from thread. There's probably ink in it. There's a plastic coating. So composition is one property that it has. Jenna?
State.
Yes, what state is it, Jenna? It's a solid. Katie?
Color.
Yes, describe its color, Katie.
Black and white.
Black and white. Is that all? This is very specific.
There's red, white, and blue.
Yes, black, white, red, and blue. What else, Brittany?
It's texture.
Its texture. How would you describe its texture, Brittany?
That kind of smooth.
It is mostly smooth, isn't it? Ashley. Yeah, how would you describe its shape, Ashley?
Like a rectangle.
Yeah, but is it two-dimensional? It's a rectangular. Huh? Prism. Yes, and it's not a perfect one because it's got rounded edges, right? What else, Devin?
It's size.
Its size, yes, and it has the size on there, 9.5 by 7.5 on this one. What else? Connor?
It's malleable.
Yes, it is malleable. Most of the scientist notebooks are flexible. You can bend them. What else? Raven?
It's opaque.
Yeah, it is opaque, isn't it? Dakota? Yeah, it has weight. Yes, we could put it on a scale and see how hard gravity's pulling on it, couldn't we? And then change that force, newtons, into pounds. Neela, what else? Huh? Yes, it has density. Yes, we could measure, its mass and its volume. And then divide. Remember, mass by volume will give us the density. Anything else? Look over the list. Is there any other? Now, let me ask you something. Does every single kind of matter have every one of those physical properties? Do you see a physical property on the list that this scientist notebook does not possess? Kylie?
Buoyancy.
Yeah, well, it'll be buoyant at first, and then as it absorbs the water, it's gonna, and it depends on what it's in, right? Raven.
Kind of.
Yes, I know you've not tested this out, but I wonder if it's really a conductor. I mean, we know energy flows through anything, but like, you know, if I wanted to, you know what, did you build circuits last year?
Yes.
Last year when you built circuits, you know, you probably had those wires, did you use the little alligator clips to attach to different parts of the circuit? Yeah, so there are different things you can buy to build the circuits, but one are the wires, they got like a little, it's almost like a clothespin, a metal clothespin on the end of it. They're called alligator clips because the mouth looks like the mouth of an alligator. And you can connect the wires from your power source, your battery, to the load, whatever it is you're trying to power, like a buzzer or a light bulb, and then back around to the battery. Or you might have a switch in there. But let's suppose that you took out part of the wire in the circuit and substituted it with this. So you had wire, battery, light bulb. Do you think the light bulb would come on?
No.
Yeah, probably not. I've never seen materials like this used as conductors. So I would say this is probably not a conductor. Any other property you see on there, physical property, that you think probably some of it doesn't have? Hayden.
It's not magnetic.
Yeah, it does not. Based on my life experiences with magnets and some of this, yeah, it's not magnetic. So my point in bringing this up is twofold. One is that not every piece of matter will have every property. Not all matter is magnetic. Not all matter is, you know, a conductor. Not all matter is malleable. Some is, some isn't, right? Some types of matter are and some types of matter aren't. However, I want to bring up another point. That when I asked you about these properties, and you told me shape and size and color and weight, let me ask you a question. When you told me the color of this scientist notebook, what did you have to do to be able to tell me?
Look at
Just look at it. Yeah. Did you have to do anything to it?
No.
No. We don't know the exact weight, but if we wanted to find the exact weight, what would we have to do to find the weight? What do we need to do? Devin?
Go to the scale.
Yeah, we need to find the scale. And then what would we do when we found the scale, Devin? Huh? Yes, but to weigh it, what would we do? Yeah, just set it on there. See what it. Take it out. Let me ask you. After you weigh it, would the scientist notebook be changed? Would it be different by weighing it?
No.
No. What about if I wanted to find its mass? What would I need to do to find its mass? Connor.
Put it in
He's forgetting the word. Do you remember? Raven?
a balance.
Put it on a balance. So we put it on a balance, either electronic or whatever, and see what the mass is. Write it down. Would it change the scientist notebook?
No.
No. Here's the first part of the trick. Give me eyes. A physical property, one way you can tell it's a physical property is you can measure that property or observe it without really changing the scientist notebook. It's still made out of the same thing as it was. But this scientist notebook also has another property. Has another property. One that we've not talked about. This bad boy is flammable. What do I mean by it's flammable? What does that mean? When I say that, oh, everybody's interested now, right? What do I mean when I say this thing is flammable? What does that mean, Neela? Yes, you can burn it. So if I wanted to observe its flammability, see it be in flames, see it in action, look what I need to do to see its flammability, to observe that it's flammable, to measure just how flammable it is. What do I need to do? Dakota? Yeah, catch it on fire. Now, so let's pretend like we caught it on fire. We looked and said, oh, yeah, it's flammable. We even got high tech and measured how much heat came off of it as it burned. So we just observed and measured its flammability. Let me ask you something. After that, would the scientist's notebook have been changed?
Yes.
Yes. So here is the trick. Stay with me. Physical properties, you can observe or measure without having to change the matter, what it's made out of. But a chemical property, the only way you can measure it or observe that property in action, flammability, is you have to change it. The only way, you may know because you've got a lot of experience with paper and wood that they burn. But if you want to observe its flammability, to measure just how quick it catches on fire, how long it takes to burn, how much heat comes off of it, you gotta burn it. And once you've done that, is it made out of the same stuff anymore?
No.
What would be left afterwards?
Ashes.
Ashes, yes. Some of it would go into the air as gases, right? Couldn't you get that pile of ashes and tons of it? No. Because it's changed, it's chemically changed. It's changed the way it's made. So it's actually, the atoms have rearranged to make something new. And some of the atoms have gone into the air. So here's the first part of the trick. If you can measure the property without having to change the matter into anything else, it's a physical property. All of those things on that list, that physical property list, you can measure or observe them without having to change the matter, what it's made out of. But now we need to make a list of chemical properties. One of them is flammability. But let me ask you, just like every single physical property doesn't apply to every single piece of matter, is every type of matter flammable? Can you think of something that when you heat it up, it doesn't catch on fire? Gabe? Well, be more specific. Fire is not matter. We need a type of matter. Fire is really energy. You're seeing energy. Kylie?
A safe.
A safe, yeah. Yeah, it wouldn't catch on fire. Would it, when it got to a certain amount of heat, what would it do?
It would melt.
Yes, now if we continue to heat it, some of it would start going into gas. And some of the things, when you heat it so much, they fall apart, so to speak. The atoms start breaking away from each other, changing in different forms. So yes, not every type of matter has that flammability property. Now, stop right here. Close your scientist notebook.